Hello, everyone. Good to hear you and good to see you all. Thank you very much for the invitation. I'm so happy to be part of this workshop, uh, especially in Zhuhai. Zhuhai and people of Jinan University, they have a special place in my heart. I worked in Zhuhai for a couple of years. I really, really treasure those memories. I met some great people. I met some great friends. So I'm a little bit sad that I'm only joining remotely, but still, it's nice to be at least remotely part of this activity. Uh, I'm also happy that I'm the last presenter today. The reason for that is that my presentation will not be a technical one. We had a lot of technical presentations, high quality theoretical work, practical work, industrial work. My presentation will be not that. Probably your brains are already a little bit tired, whole day of tutorials. So what I would like you to do is to just relax. It will be very easy talk, very relaxed, not many equations. So yeah, and I hope you will enjoy. And if you have any questions, there will be a time for that at the end. So without further ado, I have some announcement to make. I am happy to announce that a new book on ADRC will be published very, very soon. The authors of the book is Professor Gernot Herbst, a German scholar and engineer, and myself. There's a beautiful foreword written in the book by Professor Gao, which we are very, very thankful for his support with this book. It will be published by a publishing house called Birkhauser. It's part of the Springer Group, and the book is coming very, very soon. It will be available in December. So I would like to take this opportunity today to tell you a few words about this book. Um, who can use it, for who is the target audience, what can you expect in the book, what was the motivation to write the book, why now, why us. And at the end of this presentation, there will be a small surprise for everybody, but I cannot talk about it yet, so don't want to spoil anything. So please wait until the end for the small surprise. Few words about us, the authors of this book. First of all, the first author is Professor Gernot Herbst. He received his engineering and PhD degrees from Chemnitz University of Technology. He specializes in electrical engineering. He was a scientific assistant at that very university, but to me and probably to many of you, he is known as the person from Siemens who was working for the past 10 years in the area of ADRC. Many of you probably know his works. He publishes a lot in transactions on industrial electronics. Great papers, very insightful, very hands-on, very, very practical work. And since 2021, Professor Herbst has been a part of the University of Applied Sciences in Zwickau, Germany. As for myself, thank you for the introduction. So probably this information you already know. So I come from Poland, but my life has always been connected somehow to China, not only through ADRC, but only through my work and travels. So, but currently I'm back on a contract in Poland. So this is also where I'm calling from. Another question you may ask is why us? Why the two of us decided to write a book? Well, we started to work on ADRC in 2010 around-ish. And today, between Gernot and myself, we have more than 2 decades of experience. We were dealing in both theoretical and practical work related to ADRC. And through that time, in that time, we have put out a lot of work, mostly in form of scientific papers on ADRC, and our credentials in this area are are widely available if you want to check them online. So through this book that we are delivering soon, we want to combine our knowledge gained in academia. So this is mostly my part, and industry. So this is the part that Gernot mostly brings. So we wanted to bring these two worlds together to create one introductory type of book on ADRC. So with this book, we want to bring a systematic, but at the same time, easily accessible way into the world of ADRC. So as I mentioned, this type of book will be an introduction to the topic. Probably another question you may ask is, why now? So you know who, but why now? Why not 5 years ago, or why not 5 years in the future? Why now? Well, having a discussion with Gernot, we have noticed that with everything what is going on in the topic of ADRC, there's a lot of interest in academia and industry. Well, this ADRC workshop is a perfect argument for that. So there's a lot of new work coming from both academia and industry, but at the same time, it creates a problem for the newcomers, the beginners in the topic of ADRC. And for example, talking to my students and Gernot talking to his students, they get pretty overwhelmed by the number of new results on ADRC. They are not yet at that level to understand those top quality work in ADRC. They are complaining, the students are complaining that they are lacking a more systematic introduction. They don't know where to look for that because there are so many different materials online. So together with Gernot, we want to provide as I said, a comprehensive and overall and up-to-date introduction to ADRC. Our main motivation is to deliver something for the new generation of scholars, students, engineers, to give them a solid foundation they can build on and improve upon in the future if they decide to work on ADRC. So with this book, we also want to or intend to provide something which is, as I mentioned, easily accessible. It is written in clear language, and also the contents of the book are easily reproducible. So everything you will see in the book, you can do it yourself. And I will talk about it in a minute. And finally, we want to, in this book, make a connection between ADRC and classic control, because probably, or maybe most of you, or maybe all of you know that the connection is there and the connection is very solid. There is a strong connection between ADRC and classical control. So this is how the book looks like. This is the table of contents. Immediately from the start, I would like to point your attention to a two-part structure of the book. So the book is almost right in the middle, divided into two parts. And this goes back to the subtitle of the book, which is From Principles to Practice. And these two parts make that division. So the principles part are the foundations, and going practical is the practical aspects of the book. So you have this clear division also in the book. Second thing in the book I would like to point your attention to is the prelude, interlude, and postlude. So if you were ever playing a musical instrument, you know those terms, prelude, interlude, and postlude. These are this is musical nomenclature. And we use it on purpose because, as you can see by the titles, they help you to understand where you are in the book. So as you can see, prelude, this gives you a fresh look into the new topic. Then you have the look around. So you stop in the middle of the book, and you have to turn around to understand, okay, where I just come from and where I'm going next. And finally, in the postlude, this is the look ahead. So this is the future work, open questions, so everything not covered in the book. And everything else, as you can see, is the core insights of the book. So please allow me to tell maybe 1-2 sentences about each chapter to give you a idea what's in the book. So chapter 2 is the, as you can see, first contact with ADRC. And it is an example-driven, step-by-step, elementary, absolutely elementary introduction to ADRC, aiming to get an initial feel for ADRC. And through this chapter, we want to encourage the readers to use their common sense and their engineering intuition. We want to liberate them from the limiting chains of control theory versus practice and classical versus modern control division. So we don't do that here in this chapter. So we want to show alternatives. We want people to use their common sense. Do not use labels. Try to understand ADRC for what it is. And also this chapter serves as laying the foundations for the next chapters. So chapter 3 generalizes everything which was mentioned in chapter 2. But it is doing that in a stripped down, very concise way. And in this chapter, we are using standard control domain related terminology. And we are also adding a little bit of mathematical rigor. So chapter 2 was very not mathematical. Chapter 3 is repeating the stuff, generalizing it, and adding more mathematical rigor. So then chapter 4 takes this previously established fundamental ADRC version and puts it in a context of time and frequency domain. This allows us to position ADRC among the already established control methods, because analyzing ADRC in time and frequency domains helps us to use, or by doing that, we can then use the linear control techniques to analyze ADRC. And we are doing that exactly in chapter 5. Chapter 5 showcases ADRC mostly in a visual manner. As you can see by the title, it's a visual tour. So we are using a lot of graphics to represent what ADRC is. In this chapter, we go deep into the capabilities of ADRC, its limitations, and we try to build in the reader's mind an intuition, an understanding of what is actually possible with ADRC and what is not possible. Then, in chapter 6, which is called Extensions and Modifications, we are doing exactly that. So chapter 6 makes the case that ADRC should be understood as a not a single algorithm that you can just drop into something. It's a modular, flexible framework that could be tailored to your specific application. And we had a couple of examples in this workshop already. So in this chapter, we show some potential extensions and modifications of ADRC that can help the designers to develop customized solution which address specific control problems like time delay, measurement noise, and so on. Then we have this very mysterious chapter 7. Chapter 7 is the concluding chapter, as you can see, of the first part of the book. It is thus a good time to take a look back and around. Since ADRC was not conceived overnight, it has now a long history. I mean, relatively long history. We want to give the credit and to people who came before us. We want to give credit where credit is due and briefly describe the history of ADRC. And please notice that we are not doing that in the introduction. We are doing that in the middle of the book, and this is on purpose. Um, so chapter 7 is also the place where we justify why we decided in this book to mainly focus on the linear version of ADRC. And to widen the reader's horizons in terms of ADRC, in the second half of the chapter, we give a list of proposed further readings, which are not covered by this book. So the entire literature overview is done in chapter 7, which is not a typical thing, as you may know. Usually those are at the very beginning, but we on purpose put it in chapter 7, so pretty late in the book. Then we go to the second part of the book. This is the going practical part. So chapter 8 opens the second part. And as you know, since putting ADRC in practice almost always is in form of a software-based implementation, we first present several discrete time variants of ADRC. We present different styles of implementation because there are multiple ways you can implement ADRC in discrete form. And we also show how this implementation, this discrete implementation, can be optimized. For example, if you want to implement ADRC on a low computational device like a microcontroller. Then we go to practical aspects, chapter 9. This chapter examines some of the issues you can encounter when implementing a controller in the real world. And in this chapter, we focus on those aspects that are most commonly seen in practice. As you can see, input saturation, bumpless transfer, measurement noise, which is significant, and also significant dead time. Those characteristics of plant are usually appearing in real systems. That's why we wanted to focus on them here. Moving on, there's also a chapter dedicated to software implementation. So chapter 10 shows that going from principles to practice, which is the main purpose of the book, is immediately possible when it comes to ADRC, based on all the previous results of the book. And in this chapter, we demonstrate the implementation of discrete time variants in software using both model-based approaches and low-level C language code. So we have the Matlab implementation, as you can see, described in details, but we also wanted to give something more generic, not related to Matlab and MathWorks software. So we also present ADRC in its raw form. So in this case, this is the C language code. So chapter 11 puts ADRC to work, literally. We are establishing all the necessary components here in this chapter for its practical implementation. And to do that, to visualize that, we are utilizing laboratory testbeds to mimic real control problems. And I will talk about those specific examples in a minute. Then finally, we have the postlude, so chapter 12. This chapter, as I mentioned, deals with the future, both the nearest and that a bit further. So regarding the nearest future, we show what is still coming in the book, and we guide the reader to the appendices. And regarding the latter, we show what the reader can do after reading this book. So it's like an outlook for what else you can do. Because please remember, as I said, this is just an introduction to ADRC. So there are so many other possibilities, and we discuss those possibilities, at least some of them, in this chapter. So a natural question is to whom this book is addressed. So it is addressed to everybody who share a common desire, and this And this desire is to put things in perspective. The book offers something for everyone, maybe with the exception of people who expect a typical theorem proof style content, as I mentioned earlier. And on purpose, the prerequisites for studying the book are intentionally not very strict. So you don't have to be an expert in order to pick up this book. This book is literally for everybody, even if you don't have any prior knowledge of ADRC. And the book can be studied can be used as a self-study, also as a one-volume reference, and it can be used by both novices and people who are already initiated. So you can study it. You can take this book and try to study it on your own. It should be self-contained. So just by reading this one book, you will have a good understanding of ADRC, and you don't really have to pick other resources to do that. So with all this in mind, the book can be used as a textbook, as a handbook, and also as a reference manual. And therefore, we make a very bold claim here that to answer the question in this slide, so to whom is this book addressed? We have a strong feeling that it is addressed to students, practitioners, but also scientists. So let me describe what I mean by that. So for students, this can be a textbook which is part of an introductory course in control systems. So imagine you are designing a course on ADRC, then you can directly use this book. So its two-part structure organically creates a 2-semester course, in my opinion. So the first semester could cover chapters 2 to 7, so part 1 of the book, and could be focused on building the foundations of ADRC from scratch. And the second semester, so chapters 8 to 12, could take those fundamental ideas and tools and show how you can apply them in practical scenarios. I also make a claim, or we also make a claim, that it is for practitioners. So for practitioners, this book can be viewed as a compact guide how to use ADRC. So in other words, an introduction if you already have a control background in methods like, for example, PID. And also we make a claim that it is applicable to scientists because the book offers a systematic and carefully distilled body of work, being a solid foundation of ADRC one can build on. So in this figure, we wanted to provide a very subjective, I know, but very subjective suggestions to the readers on what to read next. And for the newcomers, so imagine that you are first-time reader of the book. So for the newcomers to the topic of ADRC, we recommend starting with chapter 2. So first contact with ADRC if you are a novice. Because in there we begin explaining ADRC without any assumptions. And then we advise the reader to proceed with the book in a typical chronological order. However, for those who already have some knowledge of ADRC and know the terminology associated to ADRC, we suggest starting with chapter 3, so linear ADRC, if you are already familiar with the topic. This is a good starting point for you. And then also proceed in a chronological way. However, if you are a returning reader, so this is not the first time you are taking this book, then we provide several potential paths, the choice of which depends on what particular aspect of ADRC you want to revisit. So for example, if you want to go back to the foundations, then go to chapter 2 or 3. If you're looking for deeper insights, just check out 4 and 5. If you are interested in implementation, then chapters 8 and 10 would be a good match. If you want to customize your ADRC, so if you are looking for a solution to your specific problem, then go to 9, also 6. If you want to use AD of this book as a reference manual, so you don't want to not waste, but you don't want to use your precious time to go through the book, you can directly find specific answers in the reference manual. And this linear cheat sheet, I will talk about it in a minute. So now I have to do a little bit of advertising. I was thinking, and we were thinking with Gernot, what are the selling points? How can we convince you to get interested in the book? So what are its selling points? And there are a lot, we think, the selling points, but in this presentation, I will only focus on a couple of them. So first of all, cooking recipes, then the cheat sheet, which I just mentioned. Then it's the do-it-yourself hardware, and also the C code and Matlab implementation. So let me quickly go through those. So what are cooking recipes? So this is an example from the book, page 50, chapter between time and frequency domain. And here you have something which is called a cooking recipe. So what is it? Whenever we introduce a new variant in the book, new variant of ADRC that can be put into practice, that you can actually implement, doesn't matter if it's simulation model or custom software implementation and practice, we will summarize all the required steps in the form of a cooking recipe. So let me zoom in a little bit and let's check it out, what's exactly inside. So this is the cooking recipe for ADRC in transfer function form. And in all the cooking recipes, you will see 3 steps, the 3 main steps when it comes to deploying ADRC: plant modeling, controller and observer tuning, and implementation. So in the description, those steps tells you exactly what you need to do step by step. Identify the order of the system. Identify B0 as the characteristic parameter. Then use bandwidth parameterization to get the controller and observer tuning. We are very specific in the cooking recipes. We tell the readers exactly, go to this table to get the parameters, go to this table to get parameters, go to this page. So we are literally holding the reader's hand and guide that person through the implementation. This is another example of a cooking recipe. This is from page 12020, and this is about discrete time linear ADRC. And again, same story. We have our cooking recipe for discrete time ADRC, also in transfer function form, and exactly the 3 steps you have to go through in order to do the implementation. At the end of the book, all the cooking recipes have been combined in a table to give you a easy overview what's there. So as you can see, we have a couple of continuous versions of the ADRC and a couple of discrete versions as well. Again, we have this 2-part structure, so it also makes sense. The first part is more theoretical, so this is the continuous time analysis, and the practical aspect always takes place in discrete form. So we also have that. The next one, the next selling point, is something which we call a cheat sheet. So cheat sheet is part of our appendix. And as I mentioned, the book is mostly in 99% focus on linear version of ADRC, because again, it's an introduction to the topic. So we didn't want to pay too much attention to the non-linear version. So what is cheat sheet? So cheat sheet is let me explain here. Cheat sheet is meant to serve as a comprehensive reference guide to linear ADRC. So we are repeating and summarizing all relevant equations needed to implement and tune ADRC variants. All of them that have been introduced in the book, of course. In state space form, transfer function form, continuous, discrete, and for the particularly relevant, so first and second order cases where ADRC nicely connects to PI and PID controllers, all the required coefficients are presented concisely in a tabular form. So let me give you an example. So this is, as an example, this is the continuous time ADRC in transfer function form. And on those 2 pages, because that's it, that's the entire cheat sheet for this variant. As you can see, you have here everything you need to start the implementation. You have a block diagram to give you an idea how it is implemented. You have the specific form of the control signal you have to implement. You have, so for this particular implementation, you need to implement ADRC, you need those 2 transfer functions, and they are given to you explicitly for the most popular first and second order system. So you have the exact forms of those transfer functions. So what the only thing which is missing is the parameters, and parameters are in those 2 tables. So for the first order system and for the second order system. So if you need to apply ADRC in continuous time form and transfer function form, the only thing you need to check in this book is this cheat sheet. That's why it's called cheat sheet, because it's almost like you're cheating. You don't have to read the details because everything is in a concise form. Of course, we encourage students and scholars to study where those parameters come from or where those structures come from, which is explained in the book. But if you already know that, you can quickly just check it here and start your implementation immediately. So for the cheat sheets, this is an overview of all ADRC variants discussed in the book and where to find their summary in the appendix. So to help with the decision, okay, which version of ADRC I need to implement, we encourage the reader to ask 3 questions, which are here visualized using this figure. So the first question is, okay, continuous time or discrete time? What is more? What do you need? What is interesting? What is the thing that you need? The next question is state space implementation or transfer function implementation. Depending on the decision you make here, you go to a different ADRC variant. And finally, which version of ADRC you are interested in, the classical output-based version or the non-classical version, the error-based. So you can see it almost like a 3-dimensional cube, this figure. So 3 axes. And depending on those answers to those 3 questions, you will end up with a variant that you need. So selling point number 3, I have to speed up. My time is running up. So selling point number 3 is the fact that we are using do-it-yourself hardware. And what do we mean by that? So first of all, we are using 2 types of hardware in the book. The one on the left is a temperature control problem. We are using something which is called a TC-Lab board. It's a process control system. It's temperature control using heaters. What is interesting to us and what is one of the reasons we use this system, it's very affordable. It costs maybe $20. It's an off-the-shelf system, so it's easily available on the market, and it's super easy to set up. So anybody can just plug in you using a USB cable and you are good to go. No dedicated software is needed to run it. So you don't need Matlab, you don't need Simulink. You can use Python, you can use C code with some debugger. Code Composer Studio. So it's not associated to any specific software, which is good. Nobody can afford, not everybody can afford MathWorks products, which are very expensive, as you know. So this system is a multi-input, multi-output system. It has slow dynamics and sampling. It has a very significant time delay and also very significant noise. So on the other hand, we also use a voltage control system. This is a also off-the-shelf product that you can buy from Texas Instruments, also very affordable. I think it costs $40. Again, off the shelf, easy to set up, very affordable. Again, no dedicated software is needed. You can run it using C code in Code Composer Studio, or you can use any debugger. Again, it's C code, so it's very, very generic. In this case, however, please compare it to the previous system. This one is a single input, single output system. It has very fast dynamics and very, very fast sampling. And as you can see, this choice was made very consciously by us. So we wanted to test ADRC on very, very different systems because the design process is also a bit different. So how we are using that hardware. So we are showing in the chapter about hardware implementation of ADRC, what are the usual steps you have to go through in order to implement ADRC. So for using the TC Lab example, we start with the plant modeling. We get a rough idea about the dynamics of the system. Then we show the reader what is, based on the cooking recipe and based on the questions you answered, what is the best ADRC, or what is the suggested, not the best, suggested ADRC design for this particular system. We always validate first in simulation our ADRC, then we do the validation also on the real system in experiment. So exactly the same scenario is for the voltage control problem as well. And finally, one of the selling points of the book, we think, is the C code and Matlab support. So I will go very, very quickly through that because I already talked some things about that. So imagine a situation that this is the controller that we are discussing. And in the book, you will see not only a block diagram explaining what has to be done, what are the main parts, but we are providing in the book also specific code that you can just copy and paste into your software and simply use it. So this is the listing that contains the definitions of the data structures. This is the ADRC for the first order system. And then you have the discrete time state space implementation. Here in this function, you are calculating the saturated control input. So as you can see, you can directly use those, again, just copy paste it into your program and start the implementation very, very quickly. And also in the book, we provide Matlab support. All the variants we cover in the book, we created a dedicated ADRC block set, which you can download into your Matlab. And everything that is written, explained, and talked about in the book, we provide a library for that in Matlab as well. And of course, this is connected to the book. All the terminology, all the implementation is exactly like in the book. So these two materials are very, very connected. And yeah, the block set, you can download it. We put it on Matlab File Exchange. So this is the link. So feel free to use it. So how to use this book, the book in the future. So this is the summary of my presentation. So if you want to consolidate foundations, then we highly recommend to check out chapters 2 and 3, because those are the ones that talk about the core ideas of ADRC. If you want to have a deeper understanding of ADRC, so not just the surface layer things, then we highly recommend checking out chapters 4 and 5. If you're interested in deploying things in practice, then 8 and 9 are great candidates. Also 10, of course, the software implementation. And if you want to use it as a reference manual, then you can go to the cheat sheets, to the application examples. So there are, as you can see, so many different ways into the book, depending on what you want to do. A reference manual, a tailor-made. If you want to make a tailor-make system, then definitely check out extensions and modifications. Yeah. So, even my dog is happy about that. Exactly. So, to summarize, I promised that that I will give you a small surprise at the end of the presentation. So, the surprise is as follows. So, the book will be published as an open access. So the online version of the book will be completely for free. This is made possible only by the generosity of Professor Gao and Cleveland State University, which we are very, very grateful for the financial support. So this is, I think, great news, because everybody after December or in December, everybody, students, scientists, engineers, whoever has a link to the book can download it in an electronic version. So yeah, perfect. I think free. So how to get the book? As I mentioned, electronic version will be available starting December 2024. So maybe a Christmas present. So just visit Springer. This is the publisher, and simply download it in a PDF version. Again, this is an open access book. However, if you're interested in hardcover, you can also order hardcover copy also starting December 20. If you want to get the book a bit earlier, you can also pre-order it, also from Springer. Springer is also sending books to China, so there's no problem with ordering from Springer. Yeah, I'm not sure if Amazon is still operating in China. Probably not. So if you're outside of China, then Amazon can be a good option for you. Yeah, maybe Springer will also start selling the book on Taobao. I'm not sure. But yeah, definitely, if you don't need the hardcover copy, then there's always the free electronic version. So I highly recommend checking the book. Please give us feedback. Please check the book. Let us know if you like it, if it's helpful for you, for your students, for your course creation. Yeah, we'll be very, very happy for your feedback. And that's it from my side. Thank you very much for the attention. And if you have any questions, please let me know.
Yeah. Thank you, Rafa. Give amazing presentation. And anybody have any question to discuss with Rafa? So we can give only one question. Okay.
I have a question.
到这边来，到这边来，到这边来，因为这个听不到。哎。
Yes, I'm here. Raphael, do you have somebody to work with in China to translate it into Chinese?
I do not, but I would be very, very interested in doing so.
Yeah, I highly recommend, maybe from your work from your time at the Jinan University in Zhuhai. I think it should be translated into Chinese as soon as possible. It's a very useful book. And so that's my first question. My second question, I hope it's okay to ask a couple of questions. Okay.
Of course.
I hope we still have time. My other question is, I noticed in transfer function implementation, the pre-filter part has a transfer function that improper. You have a numerator degree of 3, denominator degree of 2. What was the how do you implement a improper transfer function in that case?
Yeah, this is the theory versus practice discussion, because in fact we are arriving at an improper transfer function, but in fact the implementation is rather straightforward, because you have to artificially do a differentiation. So you add an additional order of the system, but you do it in a way that the poles of that extra system are not very dominant. So you add a part to the transfer functions that is not that dominant, which does not really influence your implementation.
Right. So you're doing something, some kind of approximation.
That
Right?
is correct.
Okay.
Mm-hmm.
Got it.
You can think of it also as adding a filter, a low-pass filter,
right. Yes.
but you are not. You have to design the filter very carefully, because the coefficient cannot cut the dynamics which you are interested in. So it has to be. So it's a bit artificial, I would say, but
right.
yeah.
So my final comment is maybe this is something you can highlight in the future. Is this controller implementation, even though you have a pole at origin in your transfer function, but it doesn't have integrator one-up problem.
Yeah.
And at least in the state space version, there's no integrator to one-up. You have a ESO and you have a PD type of control, and no one-up. In the transfer function version, you have to check it out. But in general, I think it's you have a zero steady state error without ever risking one-up, and that's a setting point I think we didn't emphasize in the past. Mike Huber wrote an article recently on a couple articles recently on the reset versus integrator control.
Mm-hmm.
And this is really a big problem with the PID. One-up, you have to do all this anti-one-up stuff. But with ADRC, there's no such problem. So that's another point I want to make. Thank you very much. Thank you for all your hard work. You and Gerbert, the hard work in making this happen. It is dearly needed for the field. In fact, I'm teaching a class next semester. I'm going to use this book. Thank you very much.
I'm so happy to hear that. Please give us feedback. Maybe we have to start work on second edition.
Oh, okay.
Right.
There are other researcher in this room. Maybe have some question should be discussed with you.
Hi, Professor. I'm a student from Southeast University, and I have a question about what do you think is the essential difference between ADRC with other control methods? You have mentioned the connection between them, but I wonder what is the biggest advantage of ADRC over other controllers?
Mm-hmm. Yeah, great question. First of all, yeah, Southeast University also has a special place in my heart, as you saw at the beginning, and probably in the introduction, it was mentioned that I did my postdoc in Professor Lee's laboratory, and yeah, I always have great memories from Nanjing. So thank you for the question. Great question. There are a couple of things when it comes to what I see or why I see ADRC as a beneficial approach. I would say one of the biggest things is, and this is a bit controversial because for me this is one of its greatest advantages, but of ADRC, but to some of people this is also considered a great disadvantage, and I will explain it just right now. So to me, the main advantage of ADRC it's simplicity. The fact that we can use linear control tools to handle nonlinear control problems is truly magnificent. Of course, there are limitations. There are things that we cannot do using this methodology. But in the past 20 years, we have noticed that there is a lot we can do using this very strong assumption. So why is it a disadvantage? I'm not sure at what stage of your career you are at as a student, but if you had an opportunity to send some papers for review, I know I have, and I received sometimes a feedback that, okay, the problem you are talking about, you are trying to solve is interesting, but the solution is too simple. It's not sophisticated enough. Which I always roll my eyes when I see this, because as people who job is to solve problems, I think our main motive and our main motivation should be to provide a solution that is as simple as possible. So some people consider that as a disadvantage. I see it as the greatest advantage of ADRC. It's simplicity, the fact that we can use linear control tools to handle nonlinear control problems. So this is the general comment. More specifically, I like the fact that ADRC is almost like a straight out of box ready to use, because it's simple, because the components are well known, state space controller, Leuenberger type observer, all the things you already know. Just put the pieces correctly together, and you have an almost out of box solution or a good start to that. And finally, I would say also the built-in, as Professor Gao mentioned, the built-in anti-windup of ADRC, which is given to us almost for free. The fact that we are using the saturated control signal in the creation of ESO automatically handles the anti-wind-up system, because the system cannot wind up if you are providing with the already saturated control system. The ESO will handle that for free. Whereas in, for example, PI or PID, you have to think of, okay, I need probably an anti-wind-up addition to my controller. In ADRC, you don't have to do it. It's built in. Yeah.
Oh, okay, thank you for your answer. It will help me. Thank you.
好的，谢谢你，谢
No
谢。
problem. If you have any further questions, please let me know. I'm sure Professor Lee has my 微信 number.